and it is rapidly melting. And by the time I retire, there will not be an Arctic ice cap. And this isn't just a professor, saying this. This is the Joint Chiefs of Staff in the Department of Defense. It's number 3 on their most critical issues, because climate change and shifts in the environment like this will destabilize countries. So my part of the game has been to study the ocean. The ocean is essentially the lungs of the planet and regulates the climate. So there's a strong interaction with the atmosphere, there's a strong interaction with the land, there's lots of arrows. Unfortunately, to understand the ocean, you have to understand how all these arrows interconnect, which require data that we don't currently have. What we've begun to appreciate is the surface ocean essentially fuels carbon down to the sediments. It's the largest carbon reserve on the planet. And most of the microscopic plants that grew 250 million years ago is the basis of all the petroleum we're burning now. So it took the Earth 200 million years to make the oil that it's taken us 200 years of industrialization to use. There's also an amazing amount of undiscovered life. Just a decade ago, they discovered in hydrothermal volcanic vents bacteria that can live at 120 degrees in boiling water, and they live within the rocks, and has huge implications for biopharmaceuticals. And so we have this undiscovered planet to go forth and do work. Unfortunately, if you're an oceanographer, the first thing you realize is the ocean is a really challenging and hard place to work. You get seasick. There's lots of storms. You don't work in storms. And I was trained the classical way, which is like this. And when you do go in storms, you break bones. And while this is a joke, it's really not. If you go out on a state-of-the-art research vessel, it moves about the speed of a 10-speed bike. And if you're studying biology, you might only be able to collect, in the traditional way, 12 samples a day. So tell me, how are we going to understand this organic soup with all those interconnected arrows? And that's where the new technologies, cloud computing and all this come together that is revolutionizing oceanography today. And so I'm going to highlight sort of just one program, but this is the movement going across the planet right now, is to build ocean networks to provide the data that will feed into the weather system. And so I'm representing the Ocean Observing Initiative, but essentially it's a large consortium of universities across the country to build a new, essentially, science infrastructure for the country. And it has locations in the North Atlantic, North Pacific, and deep ocean moorings. It's got scientific cables. It's got coastal arrays off the mid-Atlantic, blah, 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 blah. What is unique about this for